I'm Justin from Toolpath, and this is Chips and Tips. Today with me is Graham Francis from Lights Out Manufacturing, and we're going to go down a nerd rabbit hole on machine automation.
Hi, I'm Graham Francis with Lights Out Manufacturing. We are Universal Robots' top integrator for CNC machine tending, and I'm really excited to nerd out.
Now, for those who haven't already listened to it, Graham did a great episode on Within Tolerance, episode 218, so you can hear his whole backstory there. But go ahead and give us a brief introduction to yourself anyway, Graham.
Yeah, absolutely. So went from engineering into machining kind of in my off time, working as a third shift operator. And then after school, worked for a variety of different companies doing some design engineering, became the Haas CNC salesman for Idaho and Montana. In doing so, bumped into this company, which used to be called Rapid Design Solutions, and jumped ship to buy in. And we originally started by making custom robots for Microsoft, bought our own machines to manufacture our parts, didn't want to load those parts, put a robot in front of the machine, and then the neighbor said, "Hey, that's cool. Can you do that for me?" And that became our whole business.
Now, there are two moments that I've had in listening and watching you guys work that really stuck out with me. The first one was on your episode with Intolerance. I don't remember the exact quote, and I admit I didn't go back to get word for word, but you said something like, pallet loading doesn't actually reduce the amount of work you do, but it can make that work more efficient. Only part loading actually reduces the amount of work you do. And for me, we can actually go into a debate about how true that is. I mean, I think it's sort of like objectively true by the numbers, but in practice, like how much that truth matters. But it was really revelatory to me to think through that process and be like, oh, you know what? You're right. Somebody still has to load a piece of stock into every vise. And then since then, I've talked to folks who have like big pallet pools on larger machines. And somebody told me, they're like, yeah, if I want to load 20 pallets, that's an hour and a half in front of that machine. Like, I think MAMs are kind of famous for that, for taking a long time to bring pallets to you. So that has always stuck with me. And even though I think the sort of the meta in machining these days is very heavily toward pallet loading, it's always forced me to think more critically about part loading, I think. And then the second time that I was just like sort of fundamentally blown away by you guys was at IMTS. And I remember talking before IMTS 2024, and you said you were going to be machining with a cobot the whole time. You're going to bring a 5-axis robot. And I thought you guys were insane, that there was no way that you could have people walking around in a trade show and have this machine like reliably loading parts. But you did it. And I went over to your demo multiple times to sort of stand back and watch in awe. And the thing that struck me was like, okay, so you could do this. You were literally doing like, I don't know, 16 different op ones or something.
Yeah, 25.
Okay, 25. With like utter chaos happening around you at IMTS and just like people who like the most challenging machining environment I can imagine. And you guys were just stress free. Like the machine was running. I mean, other than like pouring all of your coolant all over the floor, like the robot just worked. And for me, that was a moment where I was like, okay, like it has arrived. Like if you can pull that off, then there's absolutely no reason why anybody couldn't do this in their own shop, because in a shop is way easier than with random people walking around at IMTS. So those were my two moments where I thought, okay, I need to learn a little bit more from what your guys' experience. So I appreciate you coming on today to share that. If it's okay with you, we're just going to dive right in here, and I'm going to kind of grill you, and then we'll see where it takes us.
Cool. I love
Sound
it.
good?
Let's do it.
All right. So part loading versus pallet loading. Give me your like current perspective on it.
Yeah, absolutely. There is absolutely a place for both. Now, I think most people could be doing part loading instead of pallet loading, but there is a place where pallet loading just isn't replaceable. A good example for that would be castings in high mix scenario, right? So sometimes you have these people that are doing hardware for like fancy houses, door handles, things like that, where they're doing high mix castings and they need to put a different part of the machine all the time, right? That's really hard to program a robot to pick up a bunch of random shapes 24/7. I think
Okay.
you see a lot of this with 3D printing and some of the space race parts that they're doing. That's another high mix, and you don't have a standard stock shape. But there's a lot of shops out there who are buying billet material and turning it into a shape. And now we're starting with a known flat surface. And you can absolutely automate that for high mix for the first operation. And that's kind of what we're challenging the world with.
Now, if I remember, you guys use like a vacuum suction cup gripper for op one. Is that pretty typical for you?
Yep, we really like to grab the first stop with vacuum because we can pick up on saw cut material. You can pick up on a part that's round and covered in coolant. As machinists, it's like definitely non-intuitive because we're used to holding parts of vacuum in the machine, and the minute you hit that thing with an end mill, it just chucks it in your window. But
Right.
I don't need to put any force in the part. I just need to lift it, and it's really reliable for that.
Okay. Let me press a little bit here. Op one, I get it, but op two, pallet loading seems more natural to me. Like, how do you deal with op two? Because
Absolutely.
the part's going to be sort of a random shape at that point anyway, right?
Absolutely. And that's where direct part loading today, we have some tricks up our sleeves for far in the future that's going to solve this problem. But for right now, today, I'm not even going to challenge you back. You need to load
Okay.
that some other way. So what we do is, especially with 5-axis machining, almost all of the machining happens in the first operation anyway. So we
Right.
finish all of our op ones, and those run all night. And then we come in the morning, we can load each one of those during the day and finish off that op two by hand.
Yeah, this is an area where I've been sort of rolling it around in my head quite a bit because I've become a pretty firm believer in one piece flow. But as I start to play with automation and I'm just dipping my toes in with like spindle gripping right now, my instinct is actually to batch op ones because then I can control the flip and then switch to op twos. So I find that to be an interesting sort of mental challenge for me. There is no better way to make scrap really quickly than automated runs. um,
Yeah, that's
you
very
know,
true. And this is why we push every customer we have to not batch operations. The high mix situation that we showed at IMTS is super cool. But the fact of the matter is, for that, the limiting factor is CAM programming, which is why I love talking to you. The uh, majority of our customers are using a robot to pull out a finished part every single time the door opens and load a piece of stock. And if they have batches of 40, that is the majority of our work.
another sort of mental shift for me at when watching your demo at IMTS, you had 25 parts and you guys had a grid with like I don't remember, like was it 25 different size pieces of stock? There's a lot of different size pieces of stock. And I've since talked to a number of people. You have to be a little careful because this applies to aluminum and like plastics, but maybe not to like Inconel or steel. But like you could have that grid sitting there in front of the machine and just like, okay, I'm not even there, but I'm going to make a part. What's the smallest piece of stock I have that holds the part? Machine loads it and then pulls it back out. And we should talk about that actually. When you pull it back out, you're grabbing like on the grip stock to get the part back out, right?
Yep, exactly. Grab it right in the top hat.
Okay. And do you have some sort of actuator swap from vacuum? Is like a wrist on the robot? I forget how that works.
Yep, we just have a dual gripper on our robot, one that's
Okay.
parallel pinch and the other one's vacuum. So we pinch on the top hat and then load our piece of stock in the next to the machine.
Okay. All right. What if I told you that I was willing to window machine or pot machine everything? How would that change how you'd approach automation with me?
Yeah, that's our ideal situation. We tab the world over here because then I only have an op one.
Okay. Yeah, I've been playing a lot more with like potting with with hot glue. I was going to say super glue, but hot glue. I bought some like special hot glue off Amazon that's like for pulling dents out of automotive stuff. And you can go even crazier with like blue photon stuff, but I've been very impressed with what you can get away with. To the point where I don't even really tab when I'm potting anymore,
Cool.
which has been really good for toolpath because as I start to move into like 3+2 and things like that, not having to think about tabbing is actually pretty good. So the machining strategy that I'm gravitating toward right now, and everything's subject to change, but is I'll tend to machine the part out of a pretty big piece of stock and then take it like I don't want to say take it all the way down to a top hat because I'm window machining it, but I'll window machine it, but leave like solid stock underneath the part. And then pot around that and then flip that over. I mean, on a 5-axis, you understand, like you just reload it or whatever, but pot it and then machine it out. And then I don't even have tabs, which I really like. Okay. So let's say that I'm buying a robot from you guys, a cobot. They're different. And we're going to set up something similar to what you have in You had at IMTS, I'm going to have a pretty big high mix of material. What do I worry about for work holding? What are my options? What are the mistakes you see people make there?
Yeah. One thing that's pretty unique to us is we focus on providing a system that is designed to automate however they're doing it currently. I don't want to
Okay.
change all their processes. A lot of traditional integrators and other automation systems out there require them to do new work holding or new something. And
Right.
that's really hard because with any shop, it's extremely hard to change all your processes and introduce a new thing on top of that. So we my answer would be, how are you holding the part now? And let's hold it that way. One example would be if we're holding it in soft jaws. That's what our vice actuators for. People really know us for is I can just actuate the vice they have pneumatically. But there's a lot of ways to turn what they're currently doing just into a pneumatic work holding version.
Okay. So your pneumatic actuator like attaches to the vise and turns the existing screw on the vise, right? Like Kurt vise or HWR or Lang vise, you'll hook up to any of those, right?
Yep,
Um,
exactly.
okay, so for op one, pretty typical then. You're grabbing it in like gripper jaws, just like almost anybody would. And I'm guessing you can put plenty of torque into those vices to really grab onto the material.
Yeah, we can do about 50 foot-pounds of torque. We have increased that for specialty applications. Some people need it, but
Do you recommend folks go with like a stamping unit ever? Or
HWR is so hot on not needing the stamping unit, just tighten our vise harder, that we
okay,
just provide
interesting.
that torque to the HWR vise to get the same results.
Yeah, that's because what I was wondering about is like whether the robot has enough precision. Like if you've pre-stamped the material, like a human will kind of engage the stamping things with the grippers in the vise, but if a robot is doing it, it's not going to find that center, right?
Yeah, great question. And we do really tight tolerance parts for a lot of customers that are a lot tighter tolerance than what those stamping units require, and we load them no problem.
Okay. All right. Okay. So let's say I'm convinced that I want to get an automation system, but I am now looking at cobot versus robot. Convince me one way or the other.
Yeah. So our first robot was an Epson Industrial. It was not a cobot. And then our second customer required us to use this new robot called UR. We thought it was like a toy. We were not impressed with it. Before I ran into Lights Out, was not a fan of UR. And now I had sold them alongside them for a little bit, but prior to that, every demo I got, I just thought it was a toy. I have the opposite opinion now, and I think cobot is like a four-letter word in my mind because it does such a disservice to what these are. These robots are the number one thing is they are sensitive. So I feel like traditional robots are really just dumb robots now because they can't feel anything. And all of these really tight applications we're talking about where you're trying to fit parts into some extremely high tolerance work holding, you can't place those accurately most of the time with a traditional robot because it doesn't matter how accurate your robot is unless all other it allows for variation is what it allows for because now I can kind of feel out the situation with the robot, go in and if even if a part gets suctioned onto a fixture because it's such a tight tolerance, you can use a force move to just slowly pull that out as the air escapes, for example. There's a lot of the real invention of cobots is the force torque sensor on the end of the robot arm. And so there's a lot of other robot brands out there, almost all of them, all the cobot brands that don't have force torque sensors on the end of the robot arm. They might have some minimal, like current measurement to where if it runs into somebody and they weren't able to achieve the position they were programmed to achieve in a certain amount of time that they stop. But what we love UR for is that force torque sensor that's integrated in the end of the arm that allows us to feel out stock. So
So when you're programming the load and unload, you're leveraging like a sensitive move, almost like a human would feel the part.
yep, exactly.
Is that is that hard to program? Do your customers understand how that is and can mess with it on their own? Or like do you have to come back to help them redo like what's the level of specialization we're getting to there?
So if you try to just buy a UR robot and do that yourself, you will get it figured out. They are much easier to use than a lot of robots, but it's still such a difficult task that I'd be shocked if you had a reliable production up and running within 6 months of when you bought it. Most of the time, it's a year. And what we provide to customers is a program that we have really developed in depth over a long period of time so that it's really easy to use with those advanced functions. So they're never programming a robot from scratch. They're just taking this program we gave them and then modifying the load point in the machine, and then it'll follow the sequence at that different location.
But they don't have to mess with like the force moves at the end or anything like that. The like more complicated part of that program.
Almost never. We do have some advanced users who love to do it and want to tinker with it, and you can. It's unlocked for you, but almost none of our customers are.
Okay. Um, you guys have a robot rescue program that you just made me think of. How often do you show up and like do everything for somebody? And how often are you like going in to help somebody who bought a robot and needs it integrated and they're 8 months in and just are looking for help now?
The majority of our business is new business, or at least somebody who has a UR where they want to start from scratch and they're going to scrap the rest of the system. But people do have, this investment in things other than the robot that they want to hang on to. And we do go in and help with that. And we will just do it based on an hourly rate. That's kind of something I can't promise how long it's going to take, because the thing that's special about integration is a million little pieces that we tried 400 different little plastic elbow fittings and we realized they're all broke except for one brand, right? And so that's like one example. And so when you go
Right.
into somebody else's built up system, you're not sure what you're going to walk into or how long it's going to take. So we just quote it hourly and help them out the best we can.
Mm. That one gave me a lot of pause. I mean, like I've definitely been like down a rabbit hole on a part or on an implementation or something and been like, you know what, I should have just paid somebody to help me with this. And so I think it's great that you guys offer the robot rescue. I will find somebody who went through that either with you or with a different integrator and find out if they came out the other side thinking I should have just paid the integrator at the start or whether like that pain was worth it for them. I suspect that like most people should have just paid the integrator at the start and then like a very small number of people like learned a lot and then ended up paying you to finish it off anyway.
And we realized that we're actually kind of changing our like recommended approach on that. If you want the easy button, obviously integration is the way to go. We're going to be in and out in a week for install and you'll be running lights out when we leave. But machinists love to learn. They need to learn. And you are a lot of times better off, even if you struggled a lot more to get there at the end of the line with how much knowledge you've now obtained to keep that system running and improve it along the way. So we have started offering DIY robot kits where you can bring your own robot, you buy all our hardware, and you install it yourself. And we're working on putting together a video series on how to do that. And then if you get to a point where you throw up your hands and go, I can't do it anymore. At least now I can promise you I can get that running in a week because I know what hardware you have.
Oh, I really like that. That's awesome. Okay. Well, that actually brings me to a topic I'm very interested in. Walk me through a typical install. Like you guys are going to provide all the hardware. You're going to show up. You have a week to get them running lights out. Walk me through it. What does it look like?
So we do a lot of work up front, and that's kind of the on-site is really lackluster because of how much work happens before we get there. But the week that we're on site, we show up usually pretty late on Monday because of flights, and you get in the afternoon and you unpack your toolbox and kind of get some stuff packed up and then leave for the day. Tuesday, generally you might spend a whole day just running pneumatic cables and wires around their machine. That takes a lot of time. And then usually on Wednesday, you've still got a lot of things like that to tidy up on. And you're maybe starting to push the robot into position. You're gluing down the floor plates for the robot to locate in front of the machine. And we might fire up the robot that day, prove out machine.
Hold on, back up.
Yep.
Gluing down the floor plates. Zoom in there.
Yeah.
So walk me through what it looks like to mount this robot.
So we provide 4 quarter-inch thick stainless steel floor plates that get epoxied to your floor, and that allows you to move the robot out of position. We have the only mobile robot system that repeats to location. And there's a lot of people
Okay.
out there who have like it looks like a synchro flex, but you basically bolt the end of the robot arm to it and it like learns its location if it came back. but those are really inaccurate. And we found, just like machining, the only way to get accuracy is just to bolt it to something really sturdy.
Okay.
And
All right.
so we glue the floor plates down to the floor, and then this is usually when customers start to get a little antsy because they're like, "Man, you've been here for 3 whole days, and it doesn't look like the robots just moved a couple inches back and forth, and all the cables you put in are inside the machine, so they don't know what they're looking at." And you go, hang
Right.
on." Thursday afternoons where stuff gets really interesting, and then Thursday is when we dive into doing all the programming that couldn't be pre-programmed, teaching locations inside the machine, and starting to prove out the program. And then by Friday morning, we are like almost ready to run lights out. We let it run. And there's a difference between what we would run our robot at, I think, here at the shop, and what we have to leave a customer with. Because when I walk away, that thing needs to be perfectly reliable. Where if it's running on our floor and I have to run over there and tweak something real quick, I'll set it up a lot faster and a lot sloppier than I will for a customer.
Yeah.
um, and ultimately, customers will end up doing that for themselves because they know, I'm just going to set this up real quick. I'll let it run for a couple hours. And then when I see it stop, I'll go tweak that one point that was a little off. And then they're ready to run by the end of the day, lights out.
So I'm not done grilling you about
Gr-
the floor plate thing.
Grill me.
So can I put like I've actually talked to somebody recently who's like, I bought a cobot and I want to move it between these three machines. Um, can you like bolt it to like a 96 millimeter plate? Like is 0 points for robot a thing? Or should you not do that?
So they do make quick change robot bases. There is a lot of automation stuff out there that we do not deem quality enough for CNC machine tending.
Okay.
There's a lot of applications out there where you can get by with a lack of accuracy. As we know, machining isn't one of those tasks. And
Right.
people think for some reason that the minute you put a robot in front of it, everything on the robot doesn't need to be rigid. So you see plywood in feeds, and you see, just like T6 aluminum extrusion that's like bolted together, and you think it's sturdy, but man, if that robot just flexes a little bit when it goes somewhere else, like you're off by a mile when you're trying to sneak it into a tight fixture.
Okay.
So these
So
floor plates just sit on the concrete, and then our whole robot stand, which weighs over 800 pounds, sets into location features in these plates, and
okay.
that's what makes it so rigid and accurate.
So let's say, for the sake of argument, I had a crane and I was willing to pick up your super heavy 800-pound stand. Um, could I glue multiple sets of I'm picturing cones in my head. Um, could I glue multiple sets of cones down in front of like different machines and move the robot between them?
Exactly. That's exactly what it's designed
Okay.
for. So we have a set of those 4 floor plates in front of every single machine we have. We would just glue the plates down in front of the first machine and then level the robot with its screws. And then for another location, you have 2 options. One, you can shimmy your floor plates to make the robot level with the
Ah,
same,
interesting.
or you
Interesting.
can buy a
Okay.
new set of screws and just leave those lock nuts on there. And then those screws would be for that robot location.
Got it. Okay. All right. I didn't even think about leveling the robot. That's interesting. Okay. So robot 0 points are a thing, but they need to be, you can't just like have 4 tables for your robot and like slap a 96 millimeter plate on there and like bolt that to the bottom of your robot and then move the robot around on that. That's not how it works for you guys.
No, there's just too much torque with that long arm and how much it weighs for that work holding.
Okay.
I think like 96 millimeter plate would work. It works really well for work holding because it's really close to the 0 point fixture, but that is not rigid enough of a setup when you're talking about something that's so long and so heavy.
And you guys are making these 800. I mean, I'm picturing like Schedule 2 steel pipe welded plate things, right? Okay.
Yeah, that's exactly what this is. So our base plate is an inch thick and it's 40 by 48. It's a huge heavy plate, and that's the base, and then this tube gets welded to it. So we order in the raw steel that base plates comes into us water jet cut, and then we weld it on site, and make sure everything is perfectly trammed in when we weld it, and then we send it out for powder coat.
Okay, cool. Do you use the same base plate no matter how big the robot is?
We have 2 sizes, one
Okay.
size for medium to small robots, and then one size for big robots.
define medium and small and big for me. I have no concept of what would you would consider that.
Yeah, so I would say 15 kilogram payload robots and under get on one size, and
Okay.
anything above that, 20 kg and 30 kg robots get put on larger stands.
Now I have no intuition for that. So hold on. 15 kilograms to pounds because freedom units. Okay, so 30 pounds. That's enough to do like vice loading. 30 pounds for a small vice, like a 52 millimeter vice. Okay.
Yeah, and I would say,
Um,
I mean, we've only ever installed two robots that are larger than that. It's a pretty rare stand to need to pick up that big a part. Um,
okay.
but with Yeah, 30 pounds gets you a lot. I mean, we also sell pallet systems and install pallet systems. We have quite a few of those in the field, and we just use the 12 kilogram robot for that. And I always like to just take my kilograms. This is a funny thing that works really well for robots. I double them. I know it's a little bit more than that to get to pounds, but because you have to have the weight of your gripper, it usually comes out pretty close to what your payload is for your part. So you
Okay.
get about a
All right.
24-pound payload with a 12 kilogram robot.
Now I have a vague recollection that like cobots versus robots tend to have higher sort of mass capacity. Is that right?
Yes, they absolutely do. And I think it depends on the robot, right? Because I can get a 30 kg cobot and move a 60-pound part. We've done it. That's the size robot we were using at IMTS. Traditional robots are cheap. That's the advantage of them. Cobots are so expensive compared to traditional robots. So if you want to move a really heavy part and you want to do it cheaply and you don't mind the programming headaches, traditional robots are a great option.
But just sort of generally speaking, the same physical size robot will carry more weight than a cobot.
Yes, absolutely.
You may not have an answer to this, but I don't completely understand why we're using like super 6 degree of freedom. I think cobots are more than that, right? But they're like, why don't we just use like a 3 axis motion system to do loading? Why do we need like this ultimate cobot flexibility?
Yeah, so most cobots are 6 axis. There is a couple of them there are seven. I
Okay.
will say we run into, and I'll talk about this later in the episode, issues where six isn't enough. And the reason that is because we are all used to loading parts by hand, and we have gotten very good at making work holding that allow for being loaded by hand. And so it takes a lot of finesse to try and put a part on there at a lot of funny little angles to get it into the fixture. And that's where multiple axes beyond
Okay.
three becomes so nifty.
So you think it's like that last 30 millimeters or something of getting it into the fixture where all the additional degrees of rotation really shine.
Yes, absolutely.
Interesting. Okay. All right. So you don't think you'd be super successful if I said, I want a 3 axis robot. Give me automation with a 3 axis robot.
And so I want to set a theme here for this conversation because this is what automation is, and it's trade-offs. If you have simple 3 axis parts going into two vices and it's only two ops, I could use a 3 axis robot to make that happen, but it's going to increase floor space. It's going to take up room in front of the door. We're not going to get as much stock density. It's probably going to be a little bit slower too. So
Okay.
but
Interesting.
we could do it absolutely. And you've seen those from like Haas. They have their auto parts loader that you can get for the side of some of their machines.
Right. Yeah. 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 Sure. I think like pallet loading machines, like the Haas pallet loading machine is basically a 3 axis system, right? When they swap out the table like that. But,
And they have
um,
a robot arm too. That's essentially it's got one pivot point. It goes up and down, and then it slides in and out. And so that's how they're able to like grab raw stock.
the like a lot of the pallet systems, the one on the Hermley, the HS Flex, the one that's in the MX 330, like their pallet system, those are all 3 axis systems,
Yeah.
for sure. Yeah, yeah. But they're grabbing like self-aligning fixtures, I think, which is the key of what you're saying.
Yes, and they have developed some very quality work holding. And this is what I love about automation is because I was always a work holding nerd before automation. And
Uh-huh.
automation requires you to be even more of a work holding nerd because it's more, yes, I can build a fixture that's fancy, but can I build a fixture that's cheap? and still gets the job done and is low tolerance, that's even better, right? And then we introduce the robot, and you're like, okay, but now I also need a lot of extra clearance so that this thing will still self align no matter what happens with the loading sequence.
Oh man, fixture that's cheap. I think about this a lot. I'm a super cheap person, especially here at the toolpath shop. This shop does not make toolpath money. It is a money loser for us. Um, but it's obviously important so that our software can work well. So I try to keep this place running as lean as I can. When I think about like pallet automation, and I'm like, geez, I'll spend more on work holding than I did on the robot. So why am I worried about how much this robot costs? Especially if you're going to get like I don't know, like a 50 pallet MAM or something, and then you're going to put, I mean, the pallets from Matsura cost money, and then you're going to put like a $2,000 or $1,500 vise on each of them, and you can see the effect there because like Lang has come out with their Night King vices now where they're only op1 vices. So they don't do any finish machining on them after hardening because who cares? It's just an op1 vice. And they do that to get the cost down. And so, yeah, that was another thing. I was like, okay, so, when you're thinking about scale, part loading versus pallet loading, the cost scale is very, very different. So, yeah, getting affordable but reliable, like pallets that can locate. And I guess I never thought about it exactly like that is that, there's a trade-off between like how self-aligning your fixture is and how accurate your robot needs to be, which is a really cool insight. I never thought of that before.
And you can make really, I think the biggest thing is having like a big target would be a great example. So people love to make soft jaws where the jaws, when you open the vise, they only crack open, 20 thou. A human has no problem
Right.
loading that. And even if there's stock variation in length, and even though I've got a very accurate robot, we've never struggled with robot accuracy. What we're really fighting is the incoming stock variation that is can be easily accounted for when you're loading it by hand, pushing it against the stop, but you're actually pushing that piece of stock to a different location when it's a different size to that stop. And so now I have
Or
to,
people aren't like in their head, they don't realize like, okay, every fifth piece of stock, I actually open the vise another quarter turn
yeah,
or
exactly.
something, right? Yeah. 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 Humans are like really flexible robots. Yeah. Okay. So that's a really good point. Okay. Interesting. Yeah. So like the pneumatic vise I have right now, I think only gives me like, I don't know, quarter inch of actuation or something. So you mentioned soft jaw design and like how far the jaws can open. One debate that I've gotten into a few times, and I've heard different theory on this, is like soft jaw design, right? So let's just say you had a part, I don't know, it doesn't matter. It's a round part. So you're going to make a round soft jaw, right? How many points of contact do you want on that soft jaw? Do you want like your soft jaw to be a full round profile? And I've seen people do the thing where they'll like comp it in, or just add a little bit of clearance. Um, but technically that is over constrained, right? Like, so that it seems like, so I've made soft jaws where like I have to put the part in by hand and then force it to the right or force it to the left, right? So it's, I guess, less over constrained. Which one of those designs would you prefer if you're designing soft jaws for a robot?
So one thing we almost always have to do with customers is look at their existing soft jaws, and then we just tell them to start cutting away material because most soft jaws are way over constrained, particularly on the edges of the jaws. In the faces that are on the axis of travel to open and close the vise, those different features in there are fine because you can kind of crack your jaws open and scoot the part side to side. But for, let's say, a traditional vice location in a CNC machine, the vice is opening in the Y direction. And your part, when you open your jaws, should be able to be, let's say, moved back and forth in X a little bit with those jaws open. But when you close them, it forces it into an X location. The exception
Right.
being if you're pushing to a stop.
Okay. Is the robot sensitive enough to push to a stop?
We do that with every single part.
Okay. So you would typically want like a little bit of X play in the soft jaw, and then the robot is loading the part and shoving it to the left or to the right.
Yep, exactly. Or you have jaws
Okay.
that are constraining it to force it into that X location, but it has,
Self aligning.
yep,
Yeah.
exactly, self-aligning.
Okay.
And that's a big difference between how we program robots and how every other system on the planet works because they will program the robot to go put the part in this location. Our robot actually says go down with this amount of force and then go in this
Okay.
direction in this amount of force. And then when we run into something, it then checks what that location is, compares it against the known value of what that location should be. And now we can identify whether we're on a chip or not and account for different variation in stock size.
Okay. All right. Um, I guess I think I saw you do this at IMTS, but you definitely talked about it. The cobots can get like a little probe effector, right? They're that sensitive. So you can put like a little probe tip on the end of the robot and like have it go in and probe things. Is that right?
Yep. And we usually use that for setups. If you're setting up a new part, you've just made new soft jaws for op2 or op1 location has changed, and you want to identify where that location is, we'll actually screw a ruby tip probe or just clamp it in the gripper fingers of the
In the
robot.
actuator. Yeah.
Yep.
Right.
And then we'll go over and we've written probing routines for the robot to just find that location so that people don't have to get good at teaching the location.
Oh, that's nice because then the robot is finding it within its own coordinate space and you don't have to like wrestle with the robot working with like a machine coordinate space or something.
Yep, exactly.
Okay, very cool. I don't know why I never thought about grabbing the ruby in the gripper jaws. That's really neat. I like that. Okay, so uh, getting good at soft jaw design is a prerequisite for being successful in automation. That shouldn't really be that surprising. And I have had discussions with people about like making really good self-aligning soft jaws and how you set up like tangency constraints and things like that. But I never thought about it in terms of like success with a cobot. I like that. I like that mental model a lot. And then extending that out and understanding that the more self-aligning your fixturing is, whether that's the soft jaws or the 0 point or the pallet system, the less accurate your robot needs to be. Um, and so that seems like a universal sort of thing that people can take away is whether you're using a cobot or a robot, the more self-aligning your fixturing is, the more successful you'll be because the less dependent you are on robot accuracy.
Yep, exactly. Exactly.
Okay.
Really well put.
Um, yeah, I've never thought about it like that before. Okay, so you show up at my shop, and it takes you 4 days of apparently no progress, but there is progress.
Yeah.
And then Thursday evening into Friday is when the magic starts to happen. I'm guessing that most of your customers are starting to really like hang around the machine at that point, and like look over your shoulder, like, "Hey, are you gonna make this happen?" Um, how how disruptive is it for you? Like, is it better for the customer to just like go lock themselves in the office and you'll come let them know when it's ready? Or like, do you encourage them to like sit there and watch you work?
We would absolutely get more done if we told them to go away. But with a new toy and a robot moving around the shop, not only is the person like the robot champion who's going to be programming it or the owner, whoever bought the system, is there watching, but once the robot starts moving Thursday afternoon, every employee in the building is stopping by to talk to you. And so we just embraced it. It's a great teaching opportunity. That's when yeah, we always are happy to talk.
Okay. All right. Um, are most of your installs on Haas machines? You guys totally comfortable on other controls?
We've installed on every brand. The
Okay.
number one is obviously Oz, just because they're the most out there. But then you start to find this interesting trend of the type of people to buy certain brands of machine are also the type of people who are most likely to automate. People who buy Brothers it's got to be our second most asked about machine because, and our second most installed machine, same thing here. And I don't know why that is, but it is definitely the case. So I would say it's Haas, Brother, then Fanuc, and then we start to get into some of these other controls. I would say the least likely person to integrate a robot are Mazak owners. I don't know why that is. We've done them, but they're far and fewer between.
And you guys don't have any trouble like interfacing with the controls and everything and getting the robot integrated on all of those? That would be intimidating to me. So,
Yeah, we've had a lot of practice at it, and after you learn like five different controls, you realize that like the other ones are just like, oh, okay, they do this one slightly different, but we get it all figured out. And we do integrate the robot to each machine differently depending on the project, the machine brand. And yeah, I think it's a great time to dive into like what the machine interface looks like to the robot.
yeah, go for it.
So with a Haas machine or a FANUC, we connect via Ethernet, and we run a dispatch program on the control that just runs a program by a macro
On
variable
on the machine control.
on the machine control. Yep, good
Right.
clarification there. Um, so we run a dispatch program on the CNC control that calls a subprogram from a macro variable, and then the robot just changes that macro variable over Ethernet. And then we actually run a physical, because the one thing you can't do on machines is there's no way to electronically push cycle start over Ethernet. You have to physically run a relay and connect the wires as if the robot was pressing the start button. And then we will set up other flags in that macro for saying whether the robot started the machine to make sure it wasn't a false start by somebody standing in front of it and pressing the green button. And so we'll set a flag, and then at the end of the dispatch program, it will reset that flag to know that the robot's the one who pressed the button.
Okay, so dispatch program. I'm trying to figure out if the machine control is in charge or if the robot control is in charge. So if I'm understanding correctly, like let's say I want to make, let's say 3 parts with this robot, right? I've loaded all 3 programs onto the control ahead of time. And then there's a dispatch program that's like, if variable 74 is 1, run program 1. If variable 74 is 2, run program 2, whatever. And all the robot is doing is changing the value of that variable.
Yep, that's exactly what's
Okay.
happening. And so the robot is controlling the machine, but there's different machine robot relationships there. A traditional integrator would tie everything in, whether the robot or the machine is in charge, and they would be basically inoperable without the other. Where we're really operating that machine like an operator is. So you could walk up to that machine as if the robot didn't exist at any point in time and just take over like it was running another CNC program.
Okay. Uh, how does the sort of M code interlock happen there? Is that over Ethernet as well?
So there is no M codes with that interface at all.
Oh, okay.
So it's
So the machine doesn't know when the robot is done.
the machine just finishes up like it normally would, and then
Okay.
the robot resets it and hits goes just like an operator.
Have you ever done an integration where the cobot physically presses the cycle start button?
I haven't, just because the relay and a couple of wires is so cheap.
Okay.
It's just slow to press the cycle start button with the robot, but you absolutely could.
Are you literally just like sort of piggybacking onto the exact same wiring in the control?
That's exactly what
Okay.
we're doing.
So you're just closing the contacts with like a separate relay. Okay.
Yep, exactly. Digital output on the
Um,
robot flips a relay that closes the contacts. Literally, we pull the back of the control panel off and wire right to where the start button is.
okay. But there's no interlock there. So how does the machine know when the robot is done loading a part?
The machine doesn't need to know. It doesn't, because the robot's just going to finish just like you would operate it manually.
Oh, because the machine is issuing cycle starts. So the robot is sort of in control of the sequence of events there. I
Yes.
see.
Yeah,
Okay.
exactly.
I see. So the robot is literally pretending it's a human.
Correct.
Full Skynet. Okay. And so the robot's like, its control of the, whoops, bang my mic again. Its control over the CNC is literally just changing that macro variable. So that's how it's selecting what program it wants to run. And then it is pressing the cycle start button. Okay. So it's deciding when those things are happening, and the CNC machine is none the wiser. All right. So that's, you said Haas and FANUC over Ethernet. Now, I happen to know that at least on my C0 brother, you cannot call subprograms based on a variable like that. I guess you could write a fixed macro to do it, but
Yeah.
how do you do it on the brother?
So right now we have not developed the software for the UR robot to communicate to the brother over Ethernet. There just hasn't been a
Okay.
big enough demand from brother users to um, have make the need for us to do that. So we would communicate over traditional M codes. So
Oh, okay. All right.
brother is the best for that, and I'm going to take a moment here to talk about the robot package option that every CNC salesman is going to try and sell you. The minute they find out you're putting a robot on a machine, you're buying a new machine, they're going to go, "Oh, you need the robot option." And you don't need the robot option. You don't need the robot option. That is the old traditional robot package that was developed in like the 80s for these traditional like automotive manufacturers. And it is a super deep level integration that frankly is more cumbersome and less flexible than what we can do with how we integrate the robots. And the biggest difference there being we don't want to do that because it gives you the ability to enable the safe sell signal to the machine from the robot, which means if somebody were to accidentally do something wrong, you could run that machine with the door open, or if somebody's in there and bumps the cycle start button. And with how we operate it, because it's just like an operator, that machine isn't starting unless the door is closed and you press the cycle start button. And Brother has the easiest interface because they have standard M codes that are super easy to tie into. Then you don't even need spare M codes because we only need a couple of them.
Right.
And so that's how we tie in.
So there you are doing a M code handoff. There's digital IO on the Brother, and the Brother is saying like, okay, M code ready. The robot reads that signal, loads the stock, and then flips its own M code to send back, I'm done, and cycle start. Okay.
Yep, exactly. And so they would have to
And
change the program in the CNC manually. You can't change programs on the fly with the robot like you can with these other controls.
interesting. Okay. All right. Um, well, I happen to know that we can at least read macro variables with the chatter stuff from Brother. So when you guys are ready to mess with that, we'll give you a hand, I guess. But
Cool. Yeah. I appreciate that. I think Brother's going to be super easy to integrate to over Ethernet. We've just got a lot of other projects we want to tackle first.
yeah, yeah. Um, okay, all right. So Brothers use M codes. Haas and Fanuc use Ethernet to you do a macro variable setting. And the limitation there is that with current install, the way you guys do it, the Brother's going to be running one program until you physically change the program. Somebody goes and changes the program. Um, I suppose you could program the cobot to press the buttons on the control.
Yeah, you
Uh,
certainly could. Until you get an error code, that would throw everything out of sequence. But
um, all right, I like that. So I have to be honest, the thought of integrating a robot, it sounds so much more complex than that. In my head, it's more complex than that, and you just made it sound incredibly easy. So I don't think I need your guys' help at all. I'm just gonna order a robot. It'll be fine. Um,
I think you would hook it up to the machine and be able to interface with the machine, no problem. That's actually some of the easiest parts of the whole project.
okay, all right. I am kind of fascinated. I want to see some pictures of your 0 point, your robot 0 point thing. So you'll have to send me some pictures of that. I feel like I learned something there because I really was thinking about like, why can't you just, put it on a 96 millimeter plate? But you're 100% right that like the lever arm of the robot, that work holding is not designed for that kind of situation. I have a feeling that folks who are willing to invest in automation might think that they want to move the robot around, and then in reality, they'd be like, you know what, I'm just going to buy more robots. This is too much of a pain in the butt. Um,
You have hit the nail on the head. We have
yeah.
so I tell every customer they want to move the robot, and I say, look, we have the only system you can do it, and it is easy. We move our robot down in the shop in 10 minutes, and we're up and running on another part on another CNC machine.
Hmm.
However, OEMs are different than job shops, right? Because job shops, they need to keep all their machines running all the time. And if you've got that machine running all the time, you have enough work to run that robot all the time anyway. So they never end up moving the robot.
Right. Right.
But especially because they don't understand how flexible it is. They don't think it's going to work for all their parts until they get it. And then they're like, oh, I can run all the parts that I have in this machine. I'm just going to leave it on here. But OEMs who have no problem, they're like, no, I don't have any more parts to run on that machine. That machine is just going to sit there, but I do have parts I need to run on this other machine. They do move their robot.
Okay. Um, how often do you do an install where somebody uses like one robot fixed and that robot works with two machines next to the robot?
Um, Very rarely, and we will always do whatever the customer wants. But the interesting thing that happens is, unless you have pretty long cycle times, you just end up with a really inefficient system because one machine is waiting for the other machine to get loaded. And then, because they always line up, no matter what you do over a couple of cycles, all of a sudden they hit at the same time and they're both ready, and you can't load two machines at once.
Mm. I was talking to somebody who has a mill part and then they need to load it into a laser cutter. And they want to like have it one piece flow. So the robot like loads the part into the mill and then takes it out of the mill. The mill is, it's a one-op part, vacuum work holding for this one. And then they could take it out of that and have it drop it into the laser. And then have it run the laser and then put another part. And you're right, there'd be some lost time there while the robot's like juggling all the parts. But
And I guess I was thinking about
um,
two CNC machines loading machining multiple
yeah.
of this, but with downstream processes with lasers, that's easy. That's great. I highly recommend that.
Okay. All right. What about so the other thing that I toss around in my head is that like 5-axis is great for reducing the number of setups you have to make and all of that. And in a job shop world, I think there's nothing that beats a 5-axis. But in a production world, um, I think you like at least from a capital expenditure standpoint, like 3-axis. If you have a robot, who cares if it's 4 ops? Like it doesn't matter, right? Your work holding investment's not going to be that high, and you'll get better throughput out of $300,000 CNC machines than one $300,000 5-axis, right?
Exactly. And we have installed robots where customers were debating between a robot and a 5-axis.
Okay. I think it's hard to beat 5-axis in a prototype situation just because not having to make work holding for each part saves you so much time. Um, but I think in a production environment, I think I start swinging back to like, okay, maybe 3-axis here. Um,
And that's exactly, these customers were production shops.
what is your distribution of mill versus lathe installs?
I would say it's 80-20, 80% mills.
Interesting, yeah, because lathes have had automation forever, but it's like built in bar pulling, bar pushing, parts catcher.
Exactly. Nothing beats a bar feeder. If you can do it with a bar feeder, don't look at robots. Go get yourself a bar feeder. But a lot of times the part doesn't fit through the parts catcher, or you're taking parts that don't fit through a bar feeder that need to be loaded if you end up with slugs of funny shapes or something like that.
Or you're doing like a lathe op on a like modifying a part or something. Yeah.
Mhm.
Okay. So you do some lathe installs then.
Yeah, absolutely.
Okay. Auto doors and things like that. All a strict requirement. Do you ever use the robot to open the door?
Great question. Yes, we can use the robot to open the door. No, it is a bad idea because
Okay.
the reason being, the robot is designed to account for variation. We program all of our systems around different stock variation, whether there's a chip under the part, how are we going to solve that to get the chip out and then reload the part? And if there's a chip on the door and you try to open the door, it requires a different amount of force to open the door. And now the robot goes, oh, there's something wrong here. And you can program around that. But the biggest reason being, it's slow. It's just slow.
And for the like relatively low cost of an auto door, are you usually installing the auto doors as part of your install or?
So we do it all sorts of different ways. There's kind of three main auto door categories. The first one being if you're getting a new machine and you can get an auto door on it, do it. It's going to be simpler, less expensive to just have it come from the factory. The next two options are like DIY auto door or like a really fancy installed door. We will install a door and we always are going to opt for the fancy option because auto doors are finicky and I'm not going to come back to service a robot system. I don't want to come back to service a robot system, so I'm only going to install a door I know is going to work every time for the rest of time. So Mitaco makes the best aftermarket auto door in my opinion. We've tried a lot of different brands. One I haven't tried is cncautodor.com. If the listeners have used one of those and have feedback, would love to hear about it. I'm always curious about that. But Mitaco is just bulletproof, but it is expensive.
What door is on your machine that you brought to IMTS?
That was an OEM door that we slightly modified because it didn't open quite far enough.
Okay. Yeah, I remember you were playing with that door a little bit in the setup.
Yeah, we pushed it beyond its uh, design travel limits.
Um, how is the auto door getting actuated by the robot? Is that through an M code or?
two different ways to actuate an auto door. One is the auto door has its own controller. So if it's an OEM door, it's already programmed to automatically close when you hit cycle start and open at the end of the program. So we don't actually need to do anything. We just tie into the door open sensor to verify that the door did in fact open before we enter the machine with the robot. And then if it's an aftermarket auto door, if it's a pneumatic DIY door, we'll control the whole thing with the robot from the solenoids on our stand. And
Oh,
then
okay.
if it's an aftermarket with its own control, like the Mitaco door, then I would send a digital output to the door close signal because those doors have their own buttons to open and close.
Okay, so in general, you're allowing the robot to control the door, but on a stock install, the CNC control is kind of automatically opening and closing the door for you.
Yep, correct.
Okay, but you do like a sensor to verify that it is open.
Exactly.
Okay, all right. Um, okay, you in prep for this gave me a whole bunch of interesting topics that I do want to go over. The one that caught my attention the most was singularities with lathes and fourth axis loading. So talk to me about that.
Yeah. So if you put a robot that is the base is sitting flat in front of the machine and you try to load the chuck of a lathe or chuck in a fourth axis on a mill, it aligns two of the six axes on the arm and you lose your ability to rotate the part because
Oh, okay.
it locks it to where you can only go up and down because two of the joints are lined up. There's two ways to get around that. One, you just make a end of arm tool that kicks your robot gripper off at 45 degrees, and you've now solved your problem. Or you could also rotate the base of the robot by 45 degrees.
Oh, interesting. Okay, so it's like a gimbal lock type of problem.
Exactly.
Okay. All right, very cool. I had never thought about that the robot can like get itself into a position where it sort of okay, I mean that is a singularity, right? Okay.
Even when you're standing in
Um
front of it and you're familiar with robot loading, every time you see it lock up when you're trying to load like a fourth axis, you're like, I've got six axes. Why can't I tilt this in any direction I want? And it just doesn't work that way.
does it tell you when that's happened? Are you getting like a singularity error code or is it just like maddeningly refusing to rotate and you just have to know what's going on?
You'll try to program it to rotate in a certain direction. It'll throw an alarm. It won't say it's a singularity because that's actually not a singularity. A singularity would be if you were trying to put the gripper within like the center column base of the robot base. That's like your main
Mm,
singularity zone because it's like trying to tuck up into itself. The It's just a position it can't reach is what it says. Could not reach position.
got it. Got it. Okay. Um All right. What other types of like weird problems have you run into that you want to give people a sort of a window into?
Yeah, absolutely. So I'm going to go through my list here. We talked about rigidity, mobility, and repeatability of the robot stands. So one thing is let's talk about electric grippers. So there's a lot of awesome grippers out on the market. Electric grippers are the most flexible because they're programmable. You can tell it to pick up a 1 inch block and then pick up a 2 inch block of material. The downside of electric grippers right now is they're really low force. And when you're talking about moving a 12-pound piece of material into a CNC, no matter your max force in the gripper, if you try to hold that thing straight out, it just rotates in the fingers of the gripper. And so you get bad reliability because you can't hold the part without it moving. And
Okay.
you'll see this regardless of whether you're using a cobot or a traditional robot. People always think, oh, traditional robots can move a lot faster. Um, well, first of all, no, cobots actually can move a lot faster. They're just not safe when you program to move at that speed. um, which then the second thing is you run into physics of your gripper holding your part. you can move super fast, but when even if you've got a pneumatic gripper and you get this 12-pound
Just
part
like
and
chucking the
you
part.
try to move super fast, like it just moves a little bit in those fingers. It doesn't even want to load in the jaws anymore because it moved.
That's funny. I'm picturing it like literally chucking the part out of the jaws now because you move the arm. It's like pitching. Yeah.
Oh, you absolutely could do that.
Yeah. Okay. All right. So are you're saying you would recommend usually like a pneumatic gripper?
If you're loading small parts, electric grippers are awesome. They're also really expensive. I recommend a pneumatic gripper. We've tried a number of different brands. We're currently getting ready to try another one. But so far, Shunk has been the only answer because they have super high repeatability and really strong closing force in a small form factor.
Okay. Interesting. All right. What other problems do people run into that they didn't expect?
Yeah. So one thing people they think they need to make custom fingers for their gripper. So you'll see a lot of 3D printed parts on grippers because they think they need to get super fancy with it. We have found really two main gripper styles that work for 90% of parts. Occasionally you'll run into a weird application, but by and large, just a standard set of square grippers that are 1 inch square and flat and covered in rubber is really effective for a lot of different materials and part shapes and sizes. Uh, 3D, and you don't have to make custom fingers all the time. It's it's one of those things that's hard to explain, but with creative programming practices, you can use the same set of fingers for almost all parts. You don't have to make new gripper fingers for every single new part you need to make. The pros of 3D printed parts on robots is if you program it to run into something, it is the break link in the solution.
Right. I think 3D printed, when I think 3D printed jaws, I think more about like Op2 type stuff. Um, but yeah, so I mean, typically you're loading with a suction cup. So there's no, like for Op1, you're loading with a suction cup to get it in the machine. And then the gripper is just to get it out of the machine, right?
Yep, we're grabbing the part after it's finished in Op1, flipping it to Op2, and then the gripper would also pull out the finished Op2.
Okay. And the same gripper.
Same gripper.
And you found that flat grippers work for most Op2 parts. You just sort of adjust their distance and then they grab the part fine. I guess it's just rubber, most parts, unless it's like perfectly round or something.
Exactly. And there's so few parts that people machine that don't have some sort of flat face. Even if it's a round face, we put a notch in our flat grippers, and that will also grab on a round shapes with the same gripper fingers.
Okay.
It's very rare that people have a part that you can't grab with a flat set of grippers.
Um, it sounds like you are doing some, I want to call it production, not necessarily high mix. So you're doing a lot of like integration of Op1, Op2 type stuff.
Yeah, most of our customers, over 80% of our business, is people who have to make 40 of this part, then 100 of this part. Maybe they have 500. We would consider 500 parts a production quantity. I think that's a big thing I
Okay.
found in the industry is everybody thinks they need. I talked to a guy the other day who was like, "Oh, robots would be great if I had production quantities, but I'm only making 10,000 at a time." And I'm like, "Oh my gosh, that is way beyond production from my perspective."
Like at that point, you're at 10,000 at a time. You're optimizing like your equipment to make them as fast as you can. Yeah. That's interesting. Yeah. For me, I want to drive to a place where I can do automation on like three of something. Um, like I'm really interested in making it efficient for me to make three of something. And I like kind of don't care how slow it is to make 30 of them because I'm not spindle time limited. And that's something that I think you have to sort of experience automation firsthand to realize like, okay, if I have to stand in front of a machine, then I care a lot about my spindle runtime. Um, Especially if it's like 8 minutes versus 10 minutes, because that's like an extra hour I have to stand in front of that machine if I'm making, I don't know, 50 parts or something. Um, but as soon as you put a robot on there, it's like, well, this thing's going to run. I'm not there. Like until I'm literally at, I don't know, pick some margin, like 18 hours a day of runtime or something, right? Like until I'm that spindle is spinning that long every day, then I just don't care about my runtime and my load time and how long the part changeover is, because it's not costing me anything. Maybe a little bit of electricity or something. Um, this is a topic that's really top of mind for me because as we push more and more to automate programming, one of the things that I believe very firmly is that you should be able to tell Toolpath how you like to program, and not the other way around. But there are going to be some limits to that, right? Like we do have some stuff in there we prefer, for example, adaptive roughing. Um, I'm not saying that we will never give anybody the option to turn off adaptive roughing, but like for right now, we use adaptive roughing. And if you're not interested in adaptive roughing, then like Toolpath's probably not a great fit for you, at least right now. Uh, I think people can get very hung up on how long their runtime is. And they're like, oh, I could spend 10 minutes and take 2 minutes out of the part runtime here. And like, yeah, but that was 10 minutes of your time that didn't translate into any value add for your customer. And I think the key to making that true is the robot has to be loading the part. Because otherwise you're stuck in front of the machine and it does impact you. And so I think that there's like a mental shift that has to happen there.
Oh, it's a huge mental shift. And it's one of the biggest things we fight. I have this conversation with almost every customer. They are so focused on cycle time. And I've tried to explain that concept so many different ways that running inefficiently, let's say you're not running your, the most optimized process. Okay, I could make this part by hand if I spend another hour on my CAM programming and to have some guy who's speedy fast to load this part in and out every single time. But if you don't have to spend that time loading the part or programming the part, and that machine runs, at 80% speed, but it runs all day, every day, you get unbelievably more throughput. And every one of our customers are not so, I say, like nice in how they present this to our other customers. I often, give references, and they're like, "You won't believe it. Like, you just need to run nonstop, even if it's slow, and you will be blown away at how many more parts you make."
Right. It's throughput. It's throughput that matters, not velocity, or not like instantaneous velocity. Yeah. Um, but I think the key there is that it's the robot that makes that true, and I think that's where people's intuition breaks, um, because they are still tied to this idea of like, oh, well, I'm going to have to be standing there swapping parts. So an extra hour of me standing there is time that's worth me taking out of this program. So as soon as you're not standing there anymore, now it doesn't matter. It's irrelevant.
It's irrelevant, absolutely. And a lot of customers don't even believe us until they see it for themselves. I would say almost all of them. Once they run the robot for a week, then they're like, oh my gosh, I had no idea how much cycle time didn't matter. But it's just been beaten to our heads as machinists for decades that cycle time is all that matters.
I think that the disconnect can really be very visceral because uh, if you're stuck in front of the machine versus you're not, then it's like a switch. There's no like gradual change there where like cycle time mattered a little bit, right? And we haven't even started talking about the reality that oftentimes slowing down gives you more reliable process, which is obviously very important for automation. Like process reliability matters more than almost anything else, right? And people talk about chips and all of that stuff, but also just like good tool life, consistent cutting, making sure parts don't pull out of the vise. And so oftentimes you're just better off going slow because, like you said, your throughput goes up when you have process reliability. But we don't even have to account for that. Like you could have a fairly unwell, you can't have an unreliable process, but ignoring that, just the reality of like, okay, a human is no longer glued to the machine. And so all that really matters at that point is like, when do I hit my 80% spindle utilization? And if I'm not there, then there's no effect at improving spindle time, right?
Exactly.
Um, yeah,
Exactly. And I think it's the same exact thing with robot speed. Robot speed also doesn't matter. It doesn't matter at all.
right.
If you're running 24/7 for a month straight, okay, let's talk about robot speed. I can come in there and make your robot a lot faster, but until you
Right.
can do that, doesn't matter.
Yeah. So I think, yeah, I think people like And there's basically 3 shifts in a day, right? And the robot will happily work all those shifts. And until you're driving toward that, then there's just no, like, I guess if you have process reliability issues or you're not comfortable running lights out, then sure, you can talk about like trying to drive that process faster. But I would argue that that's the wrong way to think about it. You should be trying to, like, you're giving up 60% of your available runtime to try and make like a 10% improvement in your single shift running. It just doesn't make any sense.
Exactly,
Um,
exactly.
yeah.
And the other hurdle that goes along with that, I think what we ran into in that high mix robot system, which frankly we don't sell any of those. People are looking for a robot that does multiple operations, and they're fine if it only does one part because it's really fast to set up for a new part. Um,
Okay.
but the biggest reason there is because when you're doing truly high mix, even if it's in a pallet pool, you can go into a lot of shops that have pallet pools. It takes them a lot of time to prove out that program. They don't trust what they output from the computer is going to make a good part, not break tools, not pull it out of the vise. And if people start programming with really conservative speeds and feeds of stuff they know works, just like all that stuff you were talking about, now they don't have to stand in front of the machine and hover over that feed hold button.
We run into that a lot at Toolpath. So the biggest adoption hurdle for Toolpath is setting up your tool library. Um, and it's both the amount of work you need to put in standardization, and then people are like, oh, well, usually I'll like tweak my feeds and speeds as I'm making that part standing live in front of the machine. And it's like, no, you can't. Like, you need to pick a feed and speed for boring, for roughing, for facing, and that's just what you run. And you should never think about it again. And sure, if you start running into your 80% utilization, we can start talking about improving that. But until you're there, just get the part on the machine. I've even had in our shop, I've had moments where somebody's like trying to fix a part, like rework a part. And again, it matters like how expensive your stock is, right? If you're working with like a one of one Inconel, like aerospace defense satellite part, then yeah, do whatever you need to do, but you're being paid for that time. If it's a chunk of aluminum, I'm like, don't rework a part. Never rework a part. Just throw it in the scrap bin, fix it, and make another one.
Yep,
Yeah,
absolutely. Yeah, it's
yeah.
cheap compared to time. Once you see the gains of running it over 80% spindle utilization, you're like, I will just buy an extra 20% stock. I don't even care.
Right, right. Actually, so that brings me to a question. Let's say I'm running lights out or long time. How does the robot, like, what if a part doesn't go well? Does it error out and we just stop and wait for a human to come back? Is there a recovery process? If are you using probing to like check if the part looked good and like making adjustments? Walk me through that.
So the robot is essentially going to act as as a low level operator. So
Okay.
if it's going to load a piece of stock in the machine and there's a chip under there, it's going to catch it. It's going to go, oh, I couldn't reach the location I was supposed to go to, just like an operator would. And it's going to pull that part
Okay.
out. It's going to blow it off. It's going to try and put it back. Um, and now if it doesn't load, there's something wrong beyond what just the chip being in there, whether that's a bad piece of stock. Okay. So then it's going to go and take this piece of stock. It's going to go put it on, a special area because it doesn't happen very often ago. There's something weird with this one. It's going to go grab another piece of stock, try to put that in the machine. It's going to go through the chip sequence again. If it try to load it again, if that doesn't work, it's going to stop and say, hey, and that's because there's something wrong. There's something wrong with your soft jaws. Maybe a tool broke. You can't load the part properly, or maybe somebody put the wrong size stock in the robot infeed. So at that point, you're glad it stopped.
Okay. So you guys are typically programming like a pretty basic, like, okay, move on to the next piece of stock, try one more time. And if that doesn't work, throw an error and somebody needs to come in and fix it.
Exactly, because that is a task the robot can't fix.
So circling back to what we were talking about with high utilization, I realized that it's a blessing and a curse. Um, if you are counting on that runtime and it's Friday night and it stops at like 8 p.m. on a Friday night and you needed that runtime, like somebody's coming back into the shop. Right. And so there's an interesting like secondary effect of like, okay, as you drive that utilization up, it used to be like, all right, well, I had to catch up, but I'll stay late one night to run or whatever. But because your utilization was so low, the effect of that stoppage was less. Um, And now if it stops like in the middle of a night and you lose a whole night of production, that can like the lever arm on that. So there's a secondary risk isn't the right word, but effect that you have to be aware of with automation, which is like, okay, as you drive your utilization up, uh, all of a sudden, like the effect of a work stoppage can become very, very significant.
Yeah, that's very true. We find that even without a robot, the things that are going to stop that machine are like if you're running a pallet pool, for example, um,
Mhm.
super reliable, dedicated piece of equipment. If if the things that stop that from running that require you to go into the shop are the same things that require you to go into the shop for a robot. And they're things that are just very human tasks. You know, all your tools broke because for some reason that one tap wasn't working. Oh, well, your pallet pool is going to sit and you're not going to get any parts done. You're going to have to go into the shop. So that still does happen. But because uh, robots run so efficiently, we actually find that it's really easy to catch up. Like, oh,
Mm.
like I can, unless you're really running 24/7, which is extremely rare, in which case we will put a lot, um, we'll put in some added stop gaps to that customer's system, whether it's like air gauging or in part process measurement to ensure that they're getting that 24/7 runtime. Most customers are improving their runtime from what and spindle utilization is such a funny thing because I run into so many customers that are like, oh, we have 80% spindle utilization. I'm like, wait, but you only run two shifts. Like,
Yeah,
you
it's
mean,
impossible.
yeah,
Yeah.
you mean 80% while you're there, and it's like
Right.
I'm gonna double the amount of time the machine's on. And its spindle utilization is out of 24/7 continuous runtime. How long are you running parts? And so we're usually improving that by so much that if they're usually like getting more throughput than they ever were before, that they still don't have parts to run on Sunday. So if something does happen, they're like, okay, I go load the robot on Sunday because I didn't get my tools set properly.
Uh, so I guess tool breakage detection, yes, on every tool every time with a robot?
You'll know your tools. You know which ones are going to be the problem, right? This tiny little tap that's been a problem for you for years before the robot showed up. Yeah, you should probe that tool. But your trusty roughing end mill you've been using forever, no. Just the uh, set advanced tool life management on everything. It's amazing how many shops don't use advanced tool life management. It's extremely easy to set up. I can walk. I'm going to do it right now. Everyone that's listening to this podcast, go out to your Haas control, scroll to the advanced tool life management screen, look at your tool list, scroll over to the right. It's going to show you all your max torque values for all your tools. It's already been recording that data. Immediately clear those out because it has all of your broken end mill history in there. And then let it run on a good part and look at what those values are. And then just set a number that's slightly higher on max spindle load for each of those tools. That took you 4 minutes, and you've just set up what you need for the majority of tool checks.
Okay, that makes sense, but I'm going to challenge you a little bit there.
Yeah.
Process reliability. Why not just turn on tool breakage detection for every tool every time? We established that like slow changeovers don't matter. You're losing almost nothing to do a tool break detect.
So I failed to remember my audience. You're correct. There's no downside. I would just check every
Right.
tool. I'm not going to fight you on that. I think that's wonderful and
Okay.
a great idea. But every other person I'm talking to is still worried about cycle time, cycle time, cycle time. So I'm
Okay.
not throwing all of the things at them that will slow down their cycle time because they're just going to be
Right.
too scared to
Right.
get a
Right.
robot.
I gotcha. I gotcha. But my goal here is to like go down. So like that's the point. Is like anything that would improve your reliability is worth it when you're dealing with like literally 60% more runtime availability than you would have had before because you're going from one shift to three or two shifts to three. You can afford huge increase in cycle time and still have higher throughput.
Probe every
Um,
tool.
yeah,
I'm all
yeah,
about it.
probe
I
every tool.
absolutely recommend it. And we probe a lot of tools.
Yeah. And I guess to that same effect, you said that there are a lot of brother owners who do automation. The downside being you can't have sister tools. I guess Haas would. I mean, you can get a pretty high number of tools in a Haas now. I think they even have a 120 tool changer now. Um,
Yep.
but like a brother, you're stuck with like 28 tools for the most part. So depending on the part you're making, it's hard to have sister tools. Do you do a lot of sister tool work and changing out tools and things like that, or do you find that people don't need to work with that as much?
There's always that one tool that everybody is replacing in whatever part it is. They're like, ah, this is the one that never works. That's the one we put the sister tool on. But, and same thing goes with probing. To start with, yes, probe every tool, but you're going to realize very quickly, like, oh, yeah, you're right. I've been using that one tool for months and nothing's happened. Okay, let's take that one off the tool probe list. That happens pretty quickly. A lot of customers will get a robot, start probing every tool, and immediately after just a couple days, we'll go, oh, okay, we can remove half of these out of here. And the same thing goes with sister tools.
Okay, cool. Um, what else do you want somebody thinking about a robot to know about that we haven't covered?
So I have a whole bunch of stuff, but to start with,
Go for it.
so safety. So back when the movie Terminator came out, the entire world became absolutely terrified of robots. And that transcended through laws in our country around robot safety to where the things you can run in a CNC as an operator and what the robot can do are incredibly different from a legality perspective. And
Interesting.
um, those things are slowly changing, but they are extremely stringent and it's important to know about. A lot of people think, oh, I can just buy a cobot and now it's safe. Well, that's not true. I can crank your robot up to 5 meters per second on the new UR, and that is not going to be safe for anyone. And paying attention to that and watching that is really important. We do a full safety risk assessment. The onus is still ultimately on the customer from a liability perspective, but we at least put them down the proper path to make sure they're following all of that. So we give them a safety risk assessment that meets all of the ISO standards. It's this ridiculously long document. We show them how it all works. And then program the robot accordingly. Safety scanners are just an amazing thing here. The combination of safety scanners and cobots are just this beautiful symbiosis because with
What's a safety scanner?
oh yeah, good question. So it's this 2D laser plane that exists that sees your whole shot from a 2D perspective so that when somebody is away from the robot, you can just let that thing rip at full speed and all get out. A lot of people see our systems and go, oh, I didn't know those robots move that fast. But then when somebody walks close to the robot or starts to get close to the robot, that robot will slow down into reduced mode. That is safe to be around humans and continue to operate. It doesn't stop. All these traditional robot systems out there, if you walk into where the robot is working, the thing stops and has to be reset. Where a cobot, you can just continue to have it operate, albeit slow. And the minute you walk out of the cell, it speeds back up and is ripping super fast. But being aware that safety matters, programming pneumatic grippers so that they're only closing with a very small gap between the part and the fingers so that you can't get your finger in there. A lot of
Mm.
those robot speeds that are calculated for those ISO standards are based on the speed of which you are moving the smallest object on the system. So basically poking hazards and smashing hazards. And that's really what you're documenting is, oh, I can't put my finger in here. If the part's there, I can't stick my finger in here when it's closing anyway. And so maybe it, gives you a tiny pinch, but it's not going to hurt anybody. And we talked about ISO standards, Terminator, door interlocks. There's so many shops out there who don't have safety door interlocks in their machine. I know it's handy. I am not responsible for what you do after we leave, but you have to have those on when I show up.
The the Speedio C control has the best door interlock because you can just open the door and then the machine just stops. And they got rid of that on the D, and it's sad that had to go away. But
Oh, that is a bummer.
uh,
That's cool.
the thing is that the Sile doesn't have that. My other machine doesn't have that, and so if I've been running the Brother all day, and then I open the Sile, I'll just cover myself in coolant. Yeah.
Yeah.
Um,
Oh, we've all taken a coolant bath or two. That happens.
Yeah. But the Speedio, it's just like it shuts all the coolant off, it breaks the spindle, and it's great. Yeah.
Oh, that's
But
handy.
yeah.
And they're not doing
Yeah,
that
it's
anymore.
super nice. No, I think there was like legal reasons or whatever. They had to stop it, right? The Terminator fears.
Exactly. That, and it's taking over everything. So if you're implementing your own robot, highly encourage that. Super fun journey. But just be aware that that's a real thing you need to be concerned about. Let's talk about robot programming for a minute. We covered probing. Um, and then I think a good comparison to tell people for setup time with a robot is like the first time you ran a CNC machine. Yeah, it took you all day to figure out how to write that program. Like that's absolutely going to happen on your first robot program. Even with our setup where we've provided this well-developed program, that's a month-long journey if you're trying to program from scratch. But then you get faster at it. The second time you set it up, it only takes you a couple hours. The third time, it only takes 20 minutes. I'd say we're about 20 minutes right now to set up a complicated part with the robot.
How is a robot programmed? Is it Python code or G code? Is there a user interface with like a pendant or something?
It is a user interface that runs its own UR specific program. So it's not any other major program name. It's
Okay.
it's called a .urp is the program file, UR program, and it's really user intuitive. So it's all based on point to point. And then what we implement into that is there is a back end to UR programs called scripting, which is its own programming language that allows you to do a lot more than what the user interface is capable of. And so we put in a whole bunch of scripts into our UR program. And that's really where all the magic happens when you want to get fancy and reliable and parameterized. So parameterization is huge when you're writing a robot program. Rather than have to teach a new infeed, let's say you have a 5x5 grid and then you set it up for a different part than you want a 4x4 grid, or the part size changed. Well, the part size changed. The location you're picking that part up from also just moved. And we program that with just like macro variables. So all the user has to do
Mhm.
is type in the stock size, and the robot will go to that new position automatically. So I think if people keep that in mind, if you're programming your own robot, look into parameterization, add in those codes. It's not that tricky, and it makes a big difference for the next part you set up.
They're typing that in on the cobot pendant.
Yes.
Okay.
Yep. Exactly.
Great.
Right on the robot pennant. And with our like pallet pool systems, we'll put in an HMI, but the UR is user interface is just so easy and so nice. We try to stay away from these black boxes because machinists are always like hesitant at first. And then once they figure something out, they want to do everything with it. And if you have an HMI interface over that, it only is capable of so much before you're just using the robot pendant to change this program to do this crazy thing you're interested in.
Okay.
All right. And then a new cool thing that's happening in robotics is the world is very quickly approaching digital twin for automation. So Intrinsic is Google's bet on AI in manufacturing. It's the name of their company. And they are trying to create this robot platform and have. I think Trinity has a system out with it now. And it basically allows the robot to never have to be programmed. You just get rid of the robot pendant. And then you would have basically CAM software for your robot, and you would have a digital twin. So that robot can't even run without that digital twin operating.
Mm.
And then NVIDIA is partnering with a number of brands, you are being one of them, where they're putting that AI on a physical box rather than living in the cloud to be able to make decisions. Is there a chip on my lathe tool that maybe we could pull off with the robot gripper? Check our tools before we run our next part. Or how do we identify parts that are on an infeed that aren't located at all? They're just thrown onto a table, things like that. And those are really exciting. And then we go to our integration challenges list here. It looks like you did a great job of covering a lot of these. I just wanted to give a shout out to cold saws. They're like totally underrated piece of equipment. Uh, it's difficult because a traditional bandsaw will run different pieces of material, where a cold saw is dedicated to either ferrous or non-ferrous material. But not only does it lasts a long time and it's super fast, but you get burr-free parts super accurately. And I think we're going to start seeing a lot more cold saws implemented in shops as automation grows.
Okay. All right. Because the burr can mess up the robot load. That makes sense.
And you can do a couple things to get around burrs. You can cut a little relief in the bottom of your jaws. So if there's a burr there,
Hmm.
you don't have to deburr parts, or just make sure you load burr side up on all your stock in your infeed, and then it's
Right.
above the soft
Right.
jaws.
You just tumble all your raw stock. That'll be fine.
Yeah. Oh, brutal.
The world's biggest stainless steel pin deburring system just for raw stock. Yeah.
Yeah. Oh, yeah. And those are things we're trying to avoid. It's oh, that would be a nightmare. I would never sell a robot if we needed that.
Okay. What do you think the next 5 years of cobot robot tending will look like? Walk me through it.
Oh, I think 5 years from now, you will take this 3D model. You will have already had your tool library set up in Toolpath, and you will generate your program. You'll just add it to a queue in your machine from your computer. You won't even go out there. You're going to have either a bunch of different pre-sizes cut of stock in the robot in feed,
Hmm.
or maybe that's the 7 year plan. You're going to have a cold saw with another robot arm that's going to grab the proper size stock and cut it to length and feed it to the robot that's loading to the machine. The robot will load that piece of stock, run the program, and then take that part out, load it into probably a second machine, and that will handle any Op2 work holding. There will be no window fixturing, no tabbing, no um, potting. And then that robot will pull out a finished part and sit on a conveyor belt. And packaging has already been figured out. So there will be, an inspection station in between there to make sure the part has
Do
been
you,
made properly.
this sounds awesome. Do you think it shows up to my shop in a shipping container, all ready to go?
Oh, like pre-assembled?
Yeah, like two machines, three robots, a cold saw, a stock rack, and a CMM in a shipping container. I can order as many of them as I want. I hook up power and air to the outside and shove raw stock in one side. Like how kumbaya are we here?
Yeah, I don't think it'll be in 5 years anyway. I don't think it'll be buy all at once, just because it's hard to be one company that manufactures cold saws, CNCs, robots, all of those
Mhm.
pieces and components. But I think you could use existing CNC machines that you already have and get a robot system to put in front of it to do this very thing.
Actually, so that raises a question for me. There are a lot of shops out there that maybe don't have the newest CNC machines. To be honest with you, I have no personal sense of like is 20 years old too old, but like should people worry about the age of their machine assuming it's in good shape? Like you don't it doesn't sound like from the integration standpoint that like you don't need the newest control or anything like that. You're not relying on like super modern features of controls.
No, in fact, one of the machines we run with a robot at our shop is a 2002 Akira Seiki with a Mitsubishi control, and yeah, I'll integrate to any machine. I don't care the age.
Okay. All right. So people don't need to worry about having the newest machine to get the integration going.
No, in fact, I would avoid getting the newest machine because a second machine is only gonna double your inefficiencies you have now, where a robot is gonna unlock many more hours than a second machine is gonna get you.
Okay. So you'd always vote for robot versus second spindle.
Absolutely. I'm a little biased, obviously,
Interesting.
on that topic, but it works for us here.
Cool. All right. Any other last topics you wanted to go over, Graham? If somebody's thinking about a robot but maybe is afraid of it, what would you tell them?
uh, you could call John at Metro Tech in Eugene, Oregon. He's not a fan of using his iPhone, and he runs that robot just fine.
Okay. All right.
Yeah, I think what would I tell somebody that is scared of a robot? I have struggled with that question so much that I've run out of things to tell those people. Try it. Go talk to somebody else who's using one, and believe them. I think
All right. Well, I'll be the skeptical customer here. How long is it going to take? I'm willing to write you a check right now. But I need these parts out the door, and And the HFO says they'll put a VF2 on my floor in a month. How long is it going to take you to get me up and running?
Perfect. When you get your VF2, it's going to take you about a week to get set up and running after it's installed. And I will be there the week after to install your robot, and you will be running Lights Out that week.
Okay, so
Six
if I'm
weeks.
willing to write if I'm willing to write a check, you'll have the robot running in 6 weeks.
Yes, and we do it regularly.
Okay.
That's our standard
Okay.
standard install schedule.
Okay. Um, can I ask you to give me a sort of like ballpark cost? Let's say under the 15 kilograms. So we'll just say a small to medium UR robot. Like, I mean, I can't be talking about 10 grand here, right? So more than 100, more than 200. How much is it going to cost?
So the robot's the most expensive part. A UR12E is currently $60,000 delivered with shipping, and our system is about it's 34,995. So we're at $95,000 now. And
Okay.
the other things you need to get are, if your machine doesn't have an auto door, you can kind of build your own with pneumatic cylinders, or then you need some sort of, or have us install one, but that's more expensive. And then you need some sort of pneumatic work holding as well. So whether we put a vice actuator on your vice, whether you get some Chunk self-centering vices or gimbal self-centering vices, the Haas ones, those are all great. Um, and so then you're probably into it for another, let's say 10 grand. So you're at that $100,000 mark to install a robot yourself. If you want a full turnkey from us, now we're at that 120, because I'm going to put 2 weeks worth of prep to make sure that thing runs flawlessly. And I'm going to show up on site. I'm going to install the entire thing. And not only are you going to be running lights out at the end of that 6 weeks, but I'm also going to teach you so that you have the ability and confidence to set up a second part to run after I'm not there.
Okay, so that's a good number because I run a Speedio here. I could buy another Speedio for around 120, and that would, in theory, double my output. In practice, it doesn't unless I'm running between machines or hire another operator or whatever. So I could, in theory, get 60% more than double, right? Three times, I guess, another 2 shifts out of that machine and decouple myself from that machine for the same price as one more spindle.
Exactly.
Yeah. So I've more than like I've gotten way more value out of that automation investment than I would have out of a second spindle.
Exactly. And I would say 120 is our most common sale price. Sometimes people need a really fancy system. Sometimes they need a really small system that's like a UR5 on a VF2 if they have small parts. That's, about 20 grand less than that. I can do one of those for $100,000. And if you need a really big robot, now we're talking about that $145,000 range to move a 60-pound part.
I mean, I definitely want my robot to be able to pick up my kid and chuck him across the shop. So I think that's a requirement for me. But you mentioned a UR12E. I don't know what any of these numbers mean. Can you give me like a 30-second overview of the UR naming scheme there?
Oh, great question. And they changed it to make it extra confusing. So the original UR robots, or what we call the CB series robots, didn't have the E at the end. And then they came out with the E series robots, where the UR is obviously the manufacturer, Universal Robots. The number is the payload that robot is capable of moving. And this is one thing that UR does very well compared to other robot brands, is that is full payload at full reach, at full speed, and that payload is 200 millimeters away from the tool flange of the robot. Every other robot brand out there on the market, the minute you extend that payload more than 200 millimeters, or if you want to move at full reach or full speed, that payload is dropping drastically. Then they introduced their next gen robots, which are pretty new, and they dropped the E back off. So that is your UR15, your UR20, the UR8 long, and those have half as many parts and have a different joint architecture. They do run faster and smoother. And so that's, but yeah, that number means payload.
Okay. And then the E is, I guess, the older generation now, and they've dropped it again for the newer generation.
Exactly.
But if I go old enough, the E disappears again. Okay, I follow. Cool. On All right. What other topics do you want to cover here?
A couple of just quick stories on things that are good to know about. If you're running Blazer Synergy 735, find yourself a new coolant. It eats polycarbonate like crazy. It destroys your machines. It's the number one problem coolant. We don't even install robot systems on machines that are using that coolant. Another fun story. This wasn't with a cobot, but a customer had a traditional robot and couldn't figure out why it was stopping every night at 2 in the morning. They drove them crazy for months. And finally, they watched the video footage of what was happening and zoomed in on this issue. And they realized the shop cat was running through the laser safety scanner.
The shop cat at 2 a.m. every day. Like
Yeah.
the cat was like very, very consistent. That's awesome.
So there's always, you learn all sorts of things when you're running lights out that you just like weren't expecting to be the problem that had nothing to do with what you were thinking about.
So is the solution to that problem to get rid of the cat or to train the laser system to be okay with the cat?
You train the laser system to just pause and then continue operation
Okay, all right.
instead of having to stop the system.
So what you're telling me is I do not have to get rid of my cat just because I bought a cobot.
Yes, correct.
Okay. All right. All right. All right.
That's good. Yeah, those are some fun little stories. Yeah, we talked about different work holding devices. And
You mentioned the Blazer coolant. I've seen on oil machines, the cobots that are on Willemins come with like a little yellow raincoat. Is it only when you have like oil coolant, or do you install the raincoat yourself? Or like what makes me need a raincoat on my robot?
if you have some, I would say very few of our customers are running a raincoat. Those
Okay.
robots are incredibly durable and will run for decades without any problems. If you want to take really good care of your robot and protect the seals from coolant buildup, then you can put a raincoat on it. Or if you found you have really harsh coolant on rubbers, that might be a good idea. It's a extremely rare problem. I can think of 2 customers out of well over 100 that have ever experienced a problem. But if you just are nice to your robot and you wipe it off occasionally, that's the only maintenance required. It's a pretty low task. You should be cleaning your CNC machine anyway. So
Okay. All right. But also like there's kind of no downside to a raincoat.
correct. Yeah, they're cheap insurance. I just don't like they're yellow.
Got it. Okay. So I got to get you a different color raincoat. All
Yeah,
right.
they only sell one color of raincoat. It's really frustrating.
Okay. All right. Noted. I'm gonna get you a different color.
Okay,
Yeah.
cool. Thanks. Yeah, I think that's a good list. We have modularity of a robot system is always a good thing to mention. Um, and this is why I love cobot automation is because every machine shop, if doing something totally different than what they thought they were going to be doing 2 years ago,
Hmm.
and applications change and you need to move them for different things. Use your equipment for different applications. And cobots are extremely redeployable. You can move a system to a different piece of equipment, change out end of arm tooling, and redeploy that asset for a different application.
So let's say I bought a system from you and I'm ready to start scaling up. What is is it easier? Like, can you just at that point just ship me equipment and I can, I want to copy my cell and put another cell in? How much more work, less work, the same work? Is it, am I an expert at that point and now it's just like getting another machine? We just install it? Talk to me about that.
Most of our customers buy Robot 3 are just having us ship them equipment.
Okay.
Um, and it kind of depends on scale of shop and how much they want to do themselves. Some of these big companies, they're like, "Yeah, I know how to do it. I don't care. I still want you to come do it." uh,
Right. Right.
but smaller shops, the majority of shops out there are after they experience all the learning curve that comes with installing a robot. They're like, "Oh, now I see what stuff matters, what stuff doesn't matter." Excuse me, I can do this myself. Just ship me another system. Um, as far as modularity goes, if customers have 2 vices on the table and you want to add a third vice, we already provide all of the digital inputs and outputs for various sensors, auxiliary equipment, and pneumatic valves to where if you wanted to implement a additional measurement system, you don't even have to wire that into your robot controller. You just have to put M8 and M12 plugs into our systems to be able to connect them. If you want to add a vise, the valve's already there. I've already taught you how to teach a vise. You just need to plug it in. You're ready to go.
Okay. All right. So I can add stuff to the system pretty easily.
Yeah. Even if you want a second infeed.
A second infeed, like another table. Wow. Okay.
Yep. You can just bolt that on the other side and we can move your cart to a different location and you can double the amount of stock you can hold.
Cool. Great. Okay, I'm ready to order a cobot. I'm looking forward to setting that up on our brother here.
Sweet.
I have this weird problem where, I mean, most of what we do is one-off parts, but occasionally I need to make swag. And it's very important to me personally that we make the swag. I don't want to like contract it out. And so I end up like needing some automation to make like 500 or 1,000 of something like semi-regularly, once or twice a year. And so I am legitimately interested in automation for that. Maybe someday I'll give up on us having to make our own swag, but for right now, it's a badge of honor for me. So,
You should absolutely keep that up.
okay. You are going to be my first victim for a new game we're going to play at the end of every podcast here. I learned about it from my last podcast guest, Lauren Fahey. It is over under on McMaster. So go to McMaster and let's see what the most expensive thing you can find on McMaster's website is. And I'm going to give you a 20-second timer, and then you're going to give me a price and a part number, and we're going to see how you do.
All right. I just got to McMaster.
Okay. And your mark. Wait, I got to get a timer up. Hang on. Okay. Stopwatch, reset. On your mark, get set, go. McMaster. So things that are expensive. Like, what's the most expensive thing you could imagine buying on McMaster? At first, I thought I could buy like I-beams or something.
A building, right?
Okay. All right. A building.
Yeah. Here's a house.
Yeah.
All right. All right.
A house.
Well, they call it a house. I don't know. Yeah, it's an office.
Okay. How much do you think that is?
We'll go with.
What's the most expensive one you found on this website? I mean, I'm certain.
Yeah, $16,600.
Okay. All right. I'm gonna search robot. Let's see. 40,000, 47,000, 51,000.
Yeah.
So robots are the most expensive thing I have found on McMaster.
I should have thought of that.
They do sell pedestals on McMaster.
Yeah.
How come you don't buy your pedestals from there?
We weld our
Oh,
own.
because you need the 0 point. Yeah,
and the 0 point system. But if you are running dedicated production, it's super cost effective to bolt one of those pedestals to the concrete. Super rigid setup. Great move.
Okay. Cool. All right. Well, Graham, thank you so much. It's been great. Why don't you let everybody know where they can find you online?
Yeah, go to lightsoutmfg.com. You can also find us on Instagram at lightsoutmfg. And yeah, thanks for having me.
Yeah. You want to tell us whether you're planning to show up at IMTS next year or not?
Oh, that's a good question. I'd really like to. We've been so focused on end of year installs. I haven't had time to plan that, but I've been scheming about it. It's been in the back of my mind, hoping to.
Okay, cool. All right. Well, hopefully everybody can come watch you make parts at IMTS again.
Heck yeah, that'd be great.
All right. Thanks so much, Graham.
Thanks, Justin.